Now, good evening, guys. Sorry. Okay, evening. I'm just doing this short video. I'll also send you some cool videos later tomorrow or some other days. Now, let me just briefly explain what I've said so far. In terms of carbohydrate, we said your carbohydrate is having a molecular formula of CnH2nOn. I said your N represents what? The number of carbon atom. Therefore, if your N equals to 6, then the formula will be what? C6H12O6. This is for glucose. So we said your carbohydrate contains carbon, they contain hydrogen, and they contain what? Oxygen. The three major components of your carbohydrate is your carbon, your hydrogen, your oxygen. Now, so based on the definition I gave, I said carbohydrates are polyhydroxyl aldehyde or ketone. Polyhydroxyl aldehyde or ketone. Let us split these three words: polyhydroxy, let us split aldehyde, let us split ketone. Now, whenever you hear the word polyhydroxy, your polyhydroxy means many hydroxy group. That is, your carbohydrate must contain many hydroxy group. Polyhydroxy meaning many hydroxy group. That is, for you to say that this is a carbohydrate, you must see OH group there. Now, the second one, we said they can be an aldehyde or they become what? A ketone rather. Aldehyde or ketone. These are the two major functional groups in carbohydrates, aldehyde and ketone group. I said whenever a particular monosaccharide contains aldehyde group, you call it what? An aldose. And whenever a particular carbohydrate contains a ketone, you call it what? A ketose. Aldose, ketose. Now let's talk about them in proper. If you check the term of aldehyde, both aldehyde and ketone, they both contain a carbonyl group. Your carbonyl group is in form of C double bond O. That's your carbonyl group. Carbonyl. So now, how do we differentiate between aldehyde and ketone? Your aldehyde is going to have the carbonyl group attached to an hydrogen atom. You can see that we are attaching this carbonyl group to what? Hydrogen. Whenever you are having your carbonyl group attaching to an hydrogen atom, it is representing what? Aldehyde. That is, if you check, you are having R, C double bond O, and what? Hydrogen. Those are the components of aldehyde. But in the case of ketone, what are we having? We are having R, C double bond O, and what? R prime. This is used to differentiate between one R and the second R. We're differentiating between the first one and the what? And the second R. That's why I'm using prime here. So that means the carbonyl group of this your ketone is attaching to what? Another R. Compared to this one that we have in what? The hydrogen. Then I will give an example of both. In the case of aldehyde, if you check this structure, you see that here, what are you having? You're having C double bond O attaching to what? Hydrogen. And this other one represents the what? The R. Therefore, this particular compound is an example of what? An aldose. Because it is having the same conformation like what? An aldehyde group. This compound is called glyceraldehyde. I said we're having the conformation in terms of an aldehyde group. We're having C double bond O here, and we're having what? Hydrogen with two extra carbon here. We're having two extra carbon here, like you're forming your glyceraldehyde. Based on the fact that we're having this as C double bond O and what? Hydrogen. I told you whenever you're attaching your hydrogen to a carbonyl, you are forming what? Aldehyde. This is called glyceraldehyde. Now let's go to the other one in the case of our ketone. You see that I said your ketone contains two R. R, C double bond O, and what? R prime. One major example is this. Check this compound. You are having this as CH2OH you're having the carbonyl group in between the two carbon atoms. This is your dihydroxyacetone.